I probably need a calculator. Good morning. Today we are looking at some more similarity. So we started doing this yesterday. So similar figures are exactly the same shape. So they have like all the same number of sides, and they're all look very similar, okay? But one is small and one is big, right? They're different sizes, but they are the same shape. And so if we know that things are similar, what we can do is write a whole lot of proportions. And really all we have to find are all those corresponding sides. So we can write little ratios of corresponding sides. I will look at number one. We have this lovely similarity statement. And again, this is important to read and important to understand and mark on our picture. So angle Q is going to be congruent to angle what? T. All right. And then angle R is going to be congruent to angle U. Very good. So mark your picture. Angle R is congruent to angle U. And last, angle S is congruent to angle V. Really important that we understand the orientation, because these are not oriented the same. They're sort of spun around. Now, I need to find my corresponding sides. So if I have, I'm just going to start over here, this side that's got 24, where is its corresponding side in the other figure? X plus 5. And how do we know that those are the corresponding sides?
Because the angles match up.
Yeah, we got a 2 and a 1 angle, and here we have that same 2 and a 1 angle. So I can write those as a ratio. So I'm going to do 24 over X plus 5. And so then what would I do next?
Find the ratio for 54.
Okay, so now we're going to do 54 over
36.
36. Good. So 54 over 36. Now 54 over 36, I'm looking at that and I'm thinking to myself, those are really large numbers. Do they reduce? So 54 over 36, oh, absolutely reduces. I'm going to math frac that. You can see that it actually is going to reduce to 3 over 2. And I'd much rather work with 3 over 2 than 54 over 36, right? This is why we reduce, because the math is easier. So if you see something, you might want to math frac it just to reduce it easily. Now we can cross multiply. So I'm going to cross multiply x plus 5 times 3. What is x plus 5 times 3?
Probably 3x plus 30.
15. 3x plus 15, and then I'm going to multiply 2 times 24. 2 times 24 is 48. Very good. And then what should we do next?
Minus the 15 from both sides.
Good. Minus 15. So I get 3x equals, what, 33? And that means x is 11. Beautiful. Super. Okay. Now, number 2, I can do this one a couple of different ways, but this is not too terrible here. We've got a similarity statement. And maybe I can just use the similarity statement to sort of set up my corresponding sides. I have 2 triangles here. I could, what's the strategy that I could do?
You can make another triangle.
Yeah, we can sort of redraw. So I'm going to imagine like this part, the big part is gone. I'm going to redraw that big triangle, although it doesn't look big. So this is A, and then B, and then C. So maybe I'm going to redraw this big triangle. And so I had just this little piece DB, but my triangle is actually the whole entire side. What is that whole entire side, AB? 28. Oh, how did we get that? You added them together, right? Okay. And then this BC is 2x plus 3. Okay. Now I can see from my similarity statement that side AB is going to be proportional to side AD. So I could set up that little ratio right off the bat. So I could do AB is 28 over side AD right here, which is 20. then that's going to equal to, let's see, on the other side, BC. BC is 2x plus 3 over side DE, which is right here, which is the 15. All right, so we have little pieces here. So this is one way, if you have what are overlapping triangles, this is one way that you can maybe make it a little better for yourself. I don't know if it's actually better. But I'm using that similarity statement to find those corresponding sides. What should I do with the 28 over 20?
Reduce.
Reduce it, sure, because small numbers are easier. What do they, both divide by 4? Yeah. Divide by 4, we get 7 over 5. And then I can cross multiply 5 times the 2x plus 3. What is that?
10 and 15.
10x plus 15, good. And then we're going to have 15 times 7. Calculator. 105. All right, what should we do?
Oh, minus the 15.
Minus 15, minus 15. So 10x equals 90, which means x equals 9. All right, cool. Let's look at number 3. Number 3, I like to call these bow tie triangles because, do they look like a bow tie? Okay. And a lot of students find these really confusing, so it's really important when we look at these bow tie triangles that we pay attention to this similarity statement. So again, I'm going to mark up using my similarity statement. Angle M is congruent to angle Q. Angle N is congruent to angle R. And then, of course, vertical angles are congruent, right? Really important we remember vertical angles. Can't forget those. Now that we have our triangles marked up, we can see the corresponding sides much more easily. So if I say, I'm going to start with the 24. 24 over what?
28.
Good. How did you figure 28?
Side with like the 1 mark.
The single and the triple? Yeah, the single and the triple arc marks there, so good. Is equal to what over what?
X plus 8
Mm-hmm.
over 3x.
Good. X plus 8. Yeah, good. X plus 8 over 3x minus 9. And again, we want to make sure that we're always starting from the same triangle. So I did left over right when I set up my proportion. Could I have done it the other way? Could I have done right over left and right over left? Yeah, that's totally fine as well. Okay, there's like a million ways to do it correctly. It's totally wrong to go left. Oh, actually, that's not wrong. See, it's like left, and then right, left. Like, that would be bad. So there's a bunch of ways you can do it right and one to do it wrong. What should we do with 24 over 28? Reduce for sure. They both divide by 4 again? Yeah. So divide by 4, we get 6. 28 divided by 4 is 6. It happens so much in math. Like, it's just like every third problem. All right. So cross multiply here. I have 7 times my numerator of x plus 8. 7 times the quantity x plus 8 is what? So, careful. 7x plus 56. Yeah, this is 7 times the quantity x plus 8. So you got to remember to distribute. So be very careful. We're sort of skipping a step, it turns out. And that's equal to 3x minus 9 times the 6. So again, that's 6 times 3x minus 9. We got to distribute. 6 times 3x is 18x, and 6 times negative 9 is negative 54. All right, I'm going to go ahead and subtract 7x. So I have 56 is equal to 18 minus 7 is 11x's minus 54, and then I'm going to go ahead and add 54 to both sides. That's 110. equals 11x. And divide by 11, we're going to get 10. Are we done?
No, you have
No.
PR.
Good. PR. PR, plugging it in to PR right there. We're going to plug 3 times the 10 minus 9, 21. Is there a song I don't? About 21? Huh, alright. Okay. Let's take a look at number 6. Again, I have overlapping triangles, and so we do have to be pretty darn careful. They are oriented the same way because they're nested. Overlapping triangles, nested triangles. All right. So let's see. I have information about side YZ. So let's see. YZ is right there. And on my similarity statement, YZ is the little arch there connecting Y and Z, which, of course, is similar to 3x minus 7. So that is RT. So there's a pair of corresponding sides. I can go ahead and just write those down. 2x plus 2 over 3x minus 7. 2x plus 2 came from this triangle, triangle YSZ. So I'm going to make sure I start with this side. The smaller triangle. All right, and then I need to compare that to this other information. On this side, I have this, my small triangle here. Side SZ is the last 2 letters. Do I know how long side SZ is?
Yeah.
What is it? 35. Very good. How did we get 35? 40 minus 5. Very good. So that's side SZ. So I could put 35 up top, again for my smaller triangle. And then the corresponding side on the big triangle is side ST. ST is the whole side. What is the whole side ST? 40. Good. Did we use the 5? No, we didn't. Well, we used it indirectly. So you do have to think about it a little bit. If you wanted to, you could redraw the triangles so they're a little bit more clear, but I don't think it's too bad this way. I can reduce. 30 divided by 5, we get 7 over 8. All right. So I'm going to multiply 3x minus 7 times 7, which is 3x times 7 is 21x. 7 times 7 is 49, so minus 49. And I'm going to multiply 8 times the 2x plus 2. 8 times 2x is 16x, and 8 times 2 is positive 16. I'm going to go ahead and subtract 16x. Let's see, 21 minus 16 is 5. Minus 49 equals 16, and I can add 49. So 5x equals 565.
Yeah.
Yeah, thanks. And then divide by 5. I think that's 13. Yeah, okay. Are we done? No. YZ is right there, so I need to do 2 times 13. 2 times 13 plus 2, 28. All right, questions on those? Cool. Let's do one more. Number 9.
Early shut up.
All right, number 9. Again, we have a similarity statement, and because the orientation is not there on these triangles, I'm going to mark up my picture really good. So angle A corresponds to angle F. Angle G is congruent to angle L. And angle N is congruent to angle S. So what do you guys want to do for your proportion? How do you want to set it up? 24 over what? Over X is equal to X plus 7 over 6. Beautiful. And again, we're making sure my 24 is the single and double side, and the X is the single and double arc mark side. So we're making sure we're setting corresponding sides on top of one another. All right, we got to cross multiply here. So I have X times the X plus 7. What do we get? X squared plus 7X. It's X times the quantity X plus 7, so do be careful. And then 6 times 24 is 144, I think. Thank you. Oops. All right, 6 times 24 is 144. Okay, so this is not like the others. It is got a power of 2 in there. What do we have to do to solve when there's a power of 2? The bubble thing. But before I can bubble, I need all 3 terms on one side. So I'm going to subtract the 144 to the left-hand side so that it's set equal to 0. So I have X squared plus 7X minus 144 is equal to 0. This is always setting it equal to 0. Anytime you have an equation with a power in it, you always set it equal to 0. If it's got a power of 2 or 3 or 4, which you will be doing next year and solving, then you set it equal to 0. All right, so we are going to double bubble. So I've got my 2 bubbles set up, and I know first times first has to be X squared. What times what is X squared? X times X. Now, more tricky. Last times last has to be negative 144. Well, I know that 6 times 24, negative 6 times 24, or negative 24 times 6 is, we knew that. That just came from, they gave me some factors, which is nice.
Negative 12 times 12?
Yeah, negative 12 and positive 12 is another pair that gives us negative 144. Let's see. This is also, if I know it's divisible by 6, then, yeah, I think so. 144 divided by 9, yeah, So negative 9 times 16, or negative 16 times 9. Hey, that looks like a winner right there. Which one?
The bottom.
Is it the bottom or? Negative 9 and 16 are right there. Negative 9 and positive 16. Negative 9 and positive 16. How do we know we did it right? Yeah, they give us our positive 7. But yeah, check the outer and the inner products there. So that is the 16x and the negative 9x, and that gives us our 7x that we're looking for. So there we go. So now I've got my factors. I'm going to set each bubble equal to 0. So we get x minus 9 is equal to 0. X plus 16 is equal to 0. And that allows me to solve for the x's. So what does x turn out to be here? Positive 9 and negative 16. We need to go back to our picture. I love talking about this. When I look at my picture, x is right there. And if I were to plug in for x, the length of side FL would be how long? Negative 16. Is that possible?
No.
No, length can't be negative, all right? So that answer is actually a false solution. So you always have to go back when you have higher order equations and make sure that it makes sense. 9, if I plug it in 9 for a side length is totally fine. Okay? If I plug in -16, -16 cannot be the length of a side. This is geometry. It's real things. And there's no tape measure that goes to negative length. All right? So keep that in mind. All right, you guys, that's it for me. Do you have any questions?
Nope.
Okay.